Rank of a matrix, rank of m by n matrix A is defined as the number of non-zero rows in the echelon form of A. Echelon form is being obtained using elementary row operation, right? And we have to see how many non-zero rows are obtained in the given matrix. Let's say the rank is R, which is less than or equal to m, where m is the number of rows of A, right? Then also to each non-zero rows, there correspond a pivot column of A. Okay. In that case, R must be less than or equal to n as well, where R is the number of column of A. So the rank R must satisfy these two criteria. It means that R is less than or equal to m and R is less than or equal to n. So in total, I can say R is less than or equal to minimum of mn. Okay. For example, if I have A of order 5 cross 3 matrix, okay, so what is a possible rank? So possible rank will be, possible rank R will be either 0, R1, R2, R3, because minimum of 5 and 3 will be 3 only. Okay, so if without having the matrix, I can able to tell what are the possible rank, because R0 means all entries of the element is 0, all entries of the A is 0. 1 means after reduced row echelon form or echelon form, we are going to get only one non-zero rows, which is equivalently saying that only one pivot column, right? And R equal to 2 means two non-zero rows or two pivot column we are going to get. And similarly for 3 as well. So now consider the system of linear equation Ax equal to B. So when we start writing A augmented B, assume A has rank R and B is the new column, right? So the augmented matrix can have the rank either R or R plus 1. This R is the rank of coefficient matrix. So summary on the nature of the solution. So let us discuss this in detail. So let R be the rank of the coefficient matrix and S be the rank of the augmented matrix. So augmented matrix rank can be either greater than, and which is greater than equal to 1 also, right? R plus 1. So assume the augmented matrix has rank S, okay? Then case 1, if R is strictly less than S, so what had happened in that case? System has no solution. So look, for example, if I have matrix 1 0 0 0 0 1, okay? So here A is having of rank 1 0 0 0. So after reduced row echelon form, I got this A. So what is that rank? Rank is 1. Rank of A is 1 because non-zero pivot column or non-zero rows. But in total, if I see augmented matrix, the rank will be 2, right? You see. So R will be 1 and S of augmented matrix is going to be 2, because two non-zero rows, first non-zero rows and then second non-zero rows, entire matrix I have to look. Okay, so in that case S is 2, so R is less than S condition are met. Or in other word, if you look at the next last equation, if I say x y, right? So what I will do, x times 0, y times 0, 0 times x plus 0 times y is equal to b, equal to 1, right? So 0, which implies 0 equal to 1, which is not at all possible, right? So we can say that the system is inconsistent or has no solution if R is less than S. Okay, case 2. Case 2, if R is equal to S. Now this case, in this case, the system is consistent and has a solution. But the solution might be in nature of having infinite solution or unique solution, that we will see here as a sub cases. So R is equal to n, where n is the total number of unknowns. Okay. In this case, system has unique solution. What does it mean? It means that you will get every row is non-zero, right? every row is non-zero, and that is equal to rank of the matrix. Okay, in that case what had happened, every row has pivot element. Every row has pivot element, it means that all this matrix is invertible, right? And if this matrix is invertible, then you will only get unique solution. You got it? So let's say AX equal to B you have, and if A is the matrix you are going to get, and having if you see this matrix, A is invertible, like A matrix, the rank of matrix A is having, let's say here 4 by 4 matrix if you have, so 4 by 4 matrix. Okay, so what had happened here, A is having 4 by 4 matrix, so since all columns are having pivot entry, okay, then this matrix is going to be invertible, because rank is going to be 4 and determinant is not 0. Determinant of A is non-zero for this matrix. So if determinant is not 0, A inverse very well exists. So I will pre-multiply this equation by A inverse. Okay, this equation I will pre-multiply by A inverse, and then A inverse become identity of X, which is exactly X equal to A inverse of B, and then A inverse of B gives unique solution. Okay, you got it? And of course the rank of augmented matrix B is A augmented B is also going to be 4, because R equal to S. Now another subcase, when R is strictly less than n, it means the number of unknowns. In this case, system has infinite solution, and n minus r variables correspond to non-pivot columns are free variable, and remaining r variable correspond to pivot column are expressed in terms of them. All right. So as you see from here, if this entry, if this entry is, let's say, having pivot int not pivot entry, third column, fourth column you got, so this column is having no pivot entry, right? So if this column has no pivot entry, so variable corresponding to this column, let's say x y z w, four variable, so corresponding to this column, the variable z is assumed to be free variable, and it takes whatever value it wants, so you will get infinite many solution. In that case, the number of non-zero rows, one, two, three rows are there only, right? Which is less than the number of unknowns, what we have assumed 4 by 4 matrix, so 4 rows. So which is less than 1, right? So in that case, we are going to get infinite solution. And then n minus r variable correspond to non-pivot column. So non-pivot column is only this we are taking as an example, g variable, right? So variable z is free variable. Okay, note, in some cases r is less than n, the n minus r variable correspond to non-pivot columns are referred as independent variable. Independent variable means it will take any values, right? And r variable corresponding to pivot column referred as dependent variable. That is very important note. Now let us see example. Find all values of A for which the following system has no solution, unique solution, and infinitely many solution. So now my system is x plus y minus z equal to 2, x plus 2y plus z equal to 3, x plus y plus a square minus 5 into z equal to a. So first we have to solve this system using augmented matrix. So when you see augmented matrix, the coefficients are allocated 1, 1, minus 1, 2, 1, 2, 1, 3, and 1, 1, a square minus 5, and a. So this is exactly the coefficient of the original matrix, right? Original system. So now what we have to do, since this is the non-zero entry, so make zero what elementary operation has been applied, r2 change subtracted, subtract R1 from R2, subtract R3 from R1, right? Subtract R3, subtract R1 from R3, okay? So this is you have to take care of. And then what had happened here, 0, 0 is being obtained, then move next column, lower row. Again find non-zero entry, make it this 0 as well, okay? So what had happened here is, when you make this statement, you will lead to this. So we got two non-zero pivot entries, okay? Now we have a case here. So case 1, if a square minus 4, because a is a parameter which we have to identify, is going to be 0, this is going to be 0, assume, right? It means that a square minus 4 is equal to 0, right? And a minus 2 is not equal to 0, right? That means if a square is equal to 4, a square minus 4 is equal to 0, which implies a is equal to plus minus 2. So if I take a is equal to 2, let's say for example, then what had happened? This term becomes 0 and this term becomes 0, right? And if I assume a square minus 4 is equal to 0 and a not equal to 2, so what will happen? A not equal to 0, this will not be 0, non-zero, but this will be 0. So 0 times x, 0 times y, 0 times z equal to non-zero constant. So what will happen in that case? This system becomes 0, 0, 0 and non-zero. So if you see the rank wise, the augmented matrix has the coefficient matrix has how many rows are non-zero? 1, 2. So row rank is 2. But if you see in the entire matrix, augmented matrix, then non-zero. So rank is 3. So R is 2, S is 3. R is less than S. So no solution. Or in other word, if you see 0 into 0 into 0, 0 cannot be equal to minus 4. So this is also inconsistent system. So this system has no solution and system is inconsistent. Okay, case 2. Case 2, if a square minus 4 is equal to 0, that means if a square minus 4 not equal to 0, then neither a equal to minus 2 nor a equal to 2. Then augmented matrix uh, on the dividing the last row by a square minus 4, it becomes this, right? So putting it into the RREF, we will get this, right? This matrix. So now this system, because rank of R is equal to 3 and N is equal to also 3, R is equal to N and R is equal to S, right? So argument matrix rank is equal to the rank of the coefficient matrix. Then the system has unique solution by this, okay? Because directly you can read x equal to this, y equal to this, and z equal to this. And then another case, third case, a square minus 4 equal to 0, a equal to minus 2, that means a equal to 2. Then augment matrix, if you plug, everything becomes 0, 0, right? So what had happened? The rank of the augmented matrix and rank of the coefficient matrix, right? Rank of the coefficient matrix is here, R is equal to, here R is equal to 2 and S is equal to 2, but R is less than N, which is 3. So in that case, the pivot column, this is the column where we are not getting any pivot. This is the column actually. This is the column we are not getting any pivot. So this column corresponds to variable Z, right? So variable Z is having free variable, and in that case you will have infinite solution. Okay, because first column has pivot, second column has pivot. So z is independent variable here, independent variable, and the corresponding other variables are dependent variable. That's all. Thank you.